A particle of mass m is projected with a velocity v, making an angle 45 degree with the horizontal. When the particle lands on the level ground, the magnitude of change in its momentum will be, options are given, 2 mv, mv by root 2, mv root 2, 0. Is a question from AIPMT 2008. See, you know that for a projectile motion, see, assume that we have a level ground and from there we are projecting some body. So when you are projecting something like this, so you know that initial velocity, how much is initial velocity? Let us take it as u, okay. U is the initial velocity and it's making an angle theta, in our case 45 degree, okay. Now if u is the initial velocity, and how to find out the components? You know that ux is going to be equal to, u cos 45, am I right? U cos 45. Similarly, uy, we can draw y component of this velocity, okay. Y component is going to be equal to uy, which is equal to u sin theta, fine. Now while landing, you know, the body should come down with same velocity, that is the logic. You know, velocity at which the landing happens should be same. So if this is the resultant velocity, we can split this into two components. One is horizontal component, one is vertical component. Let us take it as, the same magnitude will be there actually. Let us take it as v. So this is vx, okay, this is vy. Whatever velocity with what velocity you were throwing the body in the upward direction or at this angle initially, the body should come back and hit the ground with same net velocity. So that is the conservation of energy. Or we can say that if there is no resistance, if there is no air resistance, that should happen. So here from the expression, from the initial velocity expression, we can actually find out the final velocity expression in terms of vector. See here, initial velocity you can write down like, see, initial velocity is equal to initial velocity. So initial velocity is equal to ux or u cos theta, right? U cos theta I cap plus u sin theta j cap. Okay, this is initial velocity. Final velocity. So final velocity, you know that horizontal component is not going to vary because it's not under influence of any retarding force. So we can say that same value vx is going to be equal to u cos theta will be maintained. You know that theta is 45, we will substitute at the end of the problem. And what happened to the vy? Initially vy is in the positive y direction. In this case, while landing, the same amount of vy will be there in the minus y direction because the magnitude, the resultant of these two vx and vy should be same quantity u, okay, because you are throwing upward, the projectile in the upward direction with the velocity u. So here vy is going to be equal to minus of u sin theta. This concept we can use and find out the change in momentum. Look here. Here v, final velocity, u is initial velocity, v is final velocity. That is going to be u cos theta I cap, okay, plus how much will come? Here this is going to be negative, minus of u sin theta, right? Sin theta j cap. So this is the answer. So now we have to find out momentum, right? Change in momentum. See, momentum means, change in momentum means, so momentum is defined as mass into velocity, right? If you are trying to find out delta P is equal to mass into final velocity minus initial velocity. In our case, you have mass value, mass multiplied by final velocity, u cos theta I. See, look here, u cos theta I cap, okay, minus u sin theta j cap, okay. This minus, okay, this minus u is u cos theta I cap, then plus u sin theta j cap, okay. So when you are doing this math, u cos theta is there, u cos theta minus u cos theta, that will be vanishing. You know that this u cos theta minus of u cos theta is there. Then only thing remaining here is m multiplied by u sin theta, minus of u sin theta in j direction, minus of minus of u sine theta in the j direction. So we can add this together. So minus 2u will come, right? So when you're taking the momentum, delta p is equal to minus of 2u into sine theta will be the value, okay, in the j direction will come. So, change in momentum, if you are looking at the magnitude, multiplied by mass here, okay. So now, when you are taking the magnitude of that change in momentum is going to be equal to 2u sine theta multiplied by mass, okay. So which is equal to mass multiplied by 2u, okay, 2u into sine 45. Sine 45 is 1 by root 2, right? So 1 by root 2 and root 2 can be cancelled out. So we can say root 2 multiplied by m into u is the correct answer. In our question, initial velocity is given as v, so we can say that correct answer is root 2 m multiplied by v is the right option, okay. Let us go to the options. See, mv, correct answer is mv multiplied by root 2. The third option is the right answer.